Imagine that you're looking for a lost diamond on a beach. Every now and then it seems that something flashes among the shimmering sea of sand, but it's just a piece of glass, and disappointment comes again. Why do you think I'm trying to create such strange imaginings in your head? Because this is how I'm trying to describe the feelings of astronomers when trying to capture alien signals. Scientists have been peering into the darkness through telescopes for years, but space has remained stubbornly silent, hiding its gloomy secrets among darting meteors. True, sometimes the silence is interrupted by rare signals of unknown origin. First, though, one must understand that there are many objects in the universe that can manifest themselves in one way or another as blinding light, energetic pulsation, or radio bursts. It's about the latter, radio bursts, that we'd like to now discuss. What are these phenomena, and what sensation has recently shaken the scientific world? This autumn, astronomers were astonished by unprecedented activity in space. Over a period of just a month and a half, more than 1,600 radio signals reached Earth, whereas earlier such news was at best numbered in the dozens. It got to the point where in just 1 hour, our earthly scanning devices recorded as many as 150 signals. Scientists were shocked by this, especially since fast radio bursts are considered the most inexplicable phenomenon in the universe. What are single radio impulses, and where do they come from? Fast radio bursts are quite new to scientists. They were first discovered in 2007. Like many phenomena in the field of astronomy, the discovery was made by accident. In this case, during data analysis of pulsars. The duration of the signal was only a few milliseconds, but the energy of the event that generated it is beyond description. It's equivalent to the amount of energy emitted by our star over several days, and all of this happened in a fraction of a second. To be frank, it's hard to believe it. Nevertheless, the fact remains the radio signal was captured, so astronomers began to study it. It took a group of scientists as much as 5 years to check whether the burst of FRB 010724 really came from the depths of space and wasn't provoked, for example, by a regular old electrical appliance of some sort. So a detailed analysis showed that a radio burst with a duration of less than 5 milliseconds came from the bowels of the Dwarf galaxy called the Small Magellanic Cloud. And the distance to the object that generated this signal was incredible, about 3 billion light-years, or 1 gigaparsec. As no more signals were received, a group of scientists from the State Association of Scientific and Applied Research concluded that such phenomena are very rare in the universe. How wrong they were. To begin with, let's take a detour for a moment to study the obvious discrepancies between the duration of the signal and the energy that generated it. Doctor of Physical and Mathematical Sciences and Professor of the Russian Academy of Sciences, Sergei Popov, openly ridicules this paradox in his lectures, arguing that such radio signals cannot in any way be the result of alien life. And one must admit, from our point of view, it would be absolutely ludicrous to spend such a huge amount of energy to send just a single signal. Then the next question is, what exactly is capable of generating such powerful radio bursts? Answering this, it's worth recalling the words of the same Sergei Popov. We've already encountered a similar phenomenon regarding the study of gamma ray bursts. In Soviet times, it was believed that this type of radiation was provoked exclusively by atomic bomb explosions. So spy satellites were regularly launched to record such bursts in order to warn the government of countries participating in the Cold War about the danger. As it turned out, chance again played a leading role here. Thanks to active monitoring of outer space, it was found that objects millions of times more powerful than any atomic bomb can act as sources of gamma-ray bursts, and these monsters are ridiculously far from our planet. The final insight came only after 30 years of scrupulous observations. At first, astronomers couldn't understand where dozens of powerful signals were coming from, whether their sources within the boundaries of the solar system or far beyond our galaxy. Of course, it provoked many people to see these waves as messages of alien civilizations. Films released in the 1990s, such as Contact, contributed to the prevailing mood. The heroine, Jodie Foster, captured a similar signal, indicating intelligent life in the universe. However, it wasn't a gamma-ray burst, but a radio burst. Well, it seems they already knew something ahead of time. But this detour is taking too long already. As for gamma-ray bursts, scientists later found out which phenomenon manifested itself in this way. It turned out to be a supernova explosion. But with radio bursts, things aren't so rosy. If you carefully look at the graph, which shows the first radio signal of unknown origin, we can conclude that its source is very far from the Earth. And the energy that caused this burst to come to life is equal to 10 billion solar luminosities in 1 millisecond. Another thing is interesting. How could such power fit in the radio range? For example, the similar gamma-ray bursts are much easier to explain because they're present even on Earth during the detonation of nuclear bombs. And by the way, they almost never manifest themselves in the radio range. Of course, this did not help us get any closer to finding a solution to the mysterious bursts. Let's repeat. If this is an alien civilization, then it's extremely wasteful. So much energy was literally thrown into the wind. But as in any important case, there were small obstacles on the way to solving this puzzle that were confusing. What funny incident interfered with the astronomical investigation? The fact is that in the Australian Parkes Observatory located in New South Wales, inexplicable things were discovered. The instruments began to record similar radio signals with strange regularity. They were attributed to both aircraft in flight and lightning discharges. But the answer turned out to be more down to earth. It was an ordinary microwave oven, which was used by observatory staff. Hungry scientists sometimes opened the microwave door before it was finished cooking, and radio waves burst out and were subsequently captured by observatory equipment. When everything was finally cleared up, astronomers began to check the very first signal, FRB 010724, also known as the Lorimer burst. But according to their detailed analysis, it still turned out to be genuine and not related to terrestrial radio devices. So, was the Lorimer surge the only one recorded so far? Of course not. In 2013, after a series of false reports, the sensors again delighted astrophysicists by picking up a few more short signals. After that, a conclusion was reached that, in fact, there are a lot of such bursts in the universe, perhaps several thousand events every day. But one question remained open. What generates these signals? Until recently, scientists could only determine the location where some bursts come from. In 2019, a single pulse with code number 180924 was caught, and it turned out that it came from a distant galaxy in the constellation of the Crane, which is located at a distance of 4 billion light-years from us. But then, in 2020, for the first time, there was a discovery of a source that generated a monstrous burst, and it was a neutron star with an incredibly strong magnetic field located in the constellation Chanterelles in the Milky Way galaxy. At the moment, scientists have nothing to please the public. They're still not sure what provokes radio bursts of titanic power, and there's no single scientific hypothesis. But there are some interesting suggestions. First of all, it's worth mentioning the hypothesis of Avi Loeb, professor at the Center for Astrophysics. The scientist believes that radio bursts may be the result of the activity of some stars in our galaxy. An alternative view says that some exotic events outside of our galaxy are to blame. For example, collisions of neutron stars, the transformation of a super-heavy pulsar into a black hole, or the result of the activity of magnetars. But, as you can see, not a word about extraterrestrial civilizations. But one shouldn't think that during this time scientists haven't achieved anything. Now we have the opportunity to record signals from the same source and also catch radio bursts much more often. Very soon, things will get much more dynamic. The Chinese telescope FAST will help us with this, as well as the CHIME radio telescope installed in British Columbia, one of the provinces of Canada. The latter's able to efficiently scan the sky, detecting new radio bursts. As for the spherical telescope, located in the Chinese province of Guizhou, it will act not only as a signal catcher, but will also allow the study of the evolution of dark matter and distant galaxies, as well as solving other scientific problems. By the way, a few years ago, anyone could join the search for radio signals. What was needed for this? Just joining the SETI project, which used to let you catch radio bursts without leaving your home. This non-commercial platform was powered by the BOINC program and used the computing power of home computers. Unfortunately, the project has been frozen since April of 2020, and SETI at Home has stopped sending tasks to its users. But there are several alternative options for searching for gravitational waves, as well as creating a three-dimensional model of stellar streams. Finally, it's worth noting that the hypotheses expressed by some of these scientists are questioned by other astronomers. For example, there are about 36 magnetars in our galaxy, but for some reason the instruments have never recorded anything similar to fast radio bursts emanating from these sources. Anyway, it's definitely something to think about though, isn't it? Write your thoughts in the comments and let's discuss it. And of course, like and subscribe if you haven't done this already. How far do you think a modern probe can go into space in 44 years? What will it see outside the earthly environs, and what dangers will it meet on the way? We know the answer to the first question for sure. At this stage, an unmanned vehicle created at the end of the last century, in less than half a century, can fly about 11 billion miles, an unthinkable distance by earthly standards. This was clearly proved by Voyager 2, which for many years plowed the pitch darkness of the universe, and you won't believe how many mysteries the little space explorer revealed during its journey. Equipped with many research instruments, Voyager 2 gave astronomers a detailed description of its heroic route through the solar system on its way to distant stars. Where do we start? Perhaps from the data obtained by the probe within the solar system. But what about high-tech telescopes, you object? Haven't they been observing neighboring planets for a long time, regularly transmitting useful information about the objects? Yes, but their activities can't be compared with the work of a probe located in close proximity to a cosmic body. In the second case, the incoming information is much more informative. So, where did the Voyager 2 mission start from? It began with huge Jupiter, which, if desired, is capable of absorbing all the planets of the solar system. Of course, we already knew that our system consists of stony terrestrial objects and gas giants, and we're also aware of the ice rings of Saturn and global Jupiter hurricanes. But these are only scraps of information, the gaps in which Voyager 2, as well as its inquisitive twin brother, undertook to fill. Jupiter. Voyager 2 began sending images of Jupiter to Earth on April 24, 1979. The first images sent were of the gas giant's turbulent atmosphere. Astronomers put together a short film from a series of photographs and learned more about the principles of atmospheric circulation. Unlike Voyager 1, the second probe was very close to Jupiter's moons, Io and Europa, capturing the period of their approach. The result is amazing images of Jupiter's vast system, including crisp images of its moons Callisto, Ganymede, Europa, Io, and Amalthea. At the closest point to Jupiter, Voyager 2 was on July 9, 1979, at a distance of 4,785 miles. From this location, the probe transmitted updated data regarding the planet's clouds. 4 satellites in a ring system were rediscovered, and 17,000 new images were obtained, combined from the cameras of the 2 Voyagers. At least 80% of the surface of Ganymede and Callisto, as well as Saturn, have been mapped by astronomers. As a result, Voyager 2 to some extent repeated the photographic mission of its predecessor, and then surpassed it. Saturn. The meeting of the probe with the 6th planet of the solar system took place on August 22, 1981, 2 years after the device left Jupiter and sent the first images of the Saturnian satellite Iapetus to Earth. When Voyager 2 flew past Saturn, it was confirmed that its rings are about 980 feet thick. But this is a very average value, since in some places this parameter reaches only 10 to 100 meters. During its journey near the planet, the probe passed through the rings of Saturn at a speed of 8 miles per hour. It happened very quickly, taking just seconds. During a risky maneuver, a myriad of dust particles simultaneously pierced the metal body of the spacecraft, leaving plasma trails behind. Voyager 2 also captured Saturn's moons Hyperion, Enceladus, Tethys, Phoebe, and the newly discovered Helen, Callisto, and Calypso. Uranus. It would seem that the 2 main tasks had been completed. It's time to retire, but scientists prepared a different fate for the probe. The developers decided to send the veteran ship to Uranus. The meeting with this planet, among other things, opened up the possibility of flying to Neptune. But before that, Voyager 2 carefully studied the ghostly and remote Uranus for 5.5 hours. The probe was a pioneering human-made craft that flew past this planet. Extended observations of Uranus began on November 4, 1985. The first signals of the probe reached the Earth in about 2.5 hours. What difficulties did Voyager 2 encounter in studying this cosmic body? The most tangible problem is the lack of light. The icy planet receives 400 times less of it than the Earth. The closest approach to Uranus occurred on January 24, 1986, at a distance of approximately 50,640 miles. What iconic discoveries in this location did Voyager 2 make? The probe discovered 10 new satellites that were named after the heroes of Shakespeare's tragedies: Buck, Portia, Juliet, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca, found 2 new rings in addition to 9 already known, and recorded a magnetic field tilted 55 degrees and somewhat off-center. Voyager 2 also sent back impressive photos of Uranus' large moons. After rendezvousing with the planet on February 14, 1986, the spacecraft made a single midway gravity maneuver, the largest and most significant ever performed. Voyager 2 needed to do this to plot a route to Neptune. Neptune. The probe flew to Neptune on August 25, 1989. To do this, Voyager 2 covered about 9,980 miles, flying over the clouds of the giant planet, which turned out to be closest during the 4 orbits made when approaching them. Meanwhile, the spacecraft didn't stop its painstaking work. For example, it discovered 6 new satellites and 4 rings. Neptune itself proved to be a real box of surprises. In particular, it turned out that it's not at all calm on its surface. Hellish winds are constantly blowing there at speeds of about 68 miles or 110 kilometers per hour. And this is the smallest indicator, because the speed of atmospheric flows of some stable storms on Neptune is the highest in the solar system, reaching up to 2,400 kilometers per hour. Did the probe manage to learn anything about Neptune's atmosphere? Scanners showed that the most common element is hydrogen, although methane was also present in the atmosphere, giving Neptune a nice blue tint. 3 huge structures, presumably hurricanes, are clearly visible in the image: the Great and Small Dark Spots and Scooter. Voyager 2 also captured 2/3 of Neptune's largest moon, Triton, the coldest known body in the solar system, and a cryovolcano that pours nitrogen onto the planet's surface. Breathtaking images of Neptune's southern hemisphere captured a strange terrain that resembles a bearded melon. Voyager 2's mission to this location ended with a triumphant flyby around Neptune. It's worth noting that after studying the distant planet, the probe functioned for many more years. For example, in 2011, at a command from the center, it switched to alternative engines responsible for the navigation system. And in 2019, NASA announced that it had received data from the interstellar medium transmitted by the device. Where did Voyager 2 go next after visiting Neptune? For some time, the probe followed a course below the plane of the ecliptic and left the solar system at the turn of 35 million miles from the place of departure. After the encounter with Neptune, many Voyager 2 instruments were switched to a low-power mode to save energy. It's noteworthy that 12 years after the launch, in November 1989, NASA officially renamed the project to the more snobbish Voyager Interstellar Mission spacecraft. Instruments of secondary importance were permanently deactivated. Only 7 research gadgets continue to function on board the probe. What fate awaited the second Voyager next? By November 5, 2017, the spacecraft was about 116 astronomical units, or about 11 billion miles from Earth, moving at 9.6 miles relative to the Sun in the direction of the constellation Telescope. If Voyager 2 maintains current speed parameters, it'll take approximately 19,390 years to cover a distance of only 1 light-year. Do you want to know what significant event happened on July 8, 2019? On this day, on a command from the Voyager 2 Center, it successfully launched the maneuver trajectory correction instruments that are used to control the spacecraft for the foreseeable future. Further, on October 28, 2020, NASA re-established contact with Voyager 2, more than 11.6 billion miles away from Earth. Now, the probe is outside the influence of the Sun in the interstellar medium. By the way, the original Voyager mission was designed to implement a program called the Grand Tour, which involves a large trip to the planets of the solar system. An ambitious plan in the late 1970s was for a sophisticated space exploration craft to explore the 5 outer planets. But scientists were forced to partially freeze the project in January 1972, primarily due to unjustified costs projected at $1 billion. Instead, it was proposed to launch just 2 spacecraft to Jupiter and Saturn in 1977. Both probes were designed specifically to study the 2 gas giants, and they were far more suitable than their predecessors, Pioneers 10 and 11, launched in 1974. The mission planners suggested that if the first Voyager succeeded, they would redirect the second one to Uranus and Neptune. This could be done using gravitational maneuvers, as happened later. Each of the 2 spacecraft was equipped with a slow-scan color television camera to take pictures of cosmic bodies and their satellites. The vehicles also had an extensive set of instruments for recording magnetic, atmospheric, satellite, and other data about the planets and their satellites. Both spacecraft designs were based on the older Mariner models. Until March 7, 1977, they were known as Mariner 11 and Mariner 12. Then the head of NASA, James Fletcher, announced that they would be renamed Voyagers. But everyone's wondering what Voyager 2 is doing right now. In the dark depths of space, billions of miles from home, NASA's Voyager 2 spacecraft has become an important link in astronomical research, becoming the second probe ever to dive into interstellar space. But of course, such a serious mission didn't go smoothly. As of November 2018, NASA, as usual, kept in touch with the probe, but one day the agency staff were unable to contact the device, which was quite a surprise. This was preceded by an unprecedented event that occurred on January 28, 2020. What happened? Was the spaceship attacked by aliens, or was it swallowed up by a black hole? No, just the probe suddenly stopped moving. Voyager 2 stopped just before making its planned maneuver. The craft had to turn 360 degrees to calibrate one of the onboard instruments, but instead it didn't budge. As a result, both Voyager systems worked non-stop, consuming huge amounts of energy. So what was the problem? The spacecraft used up the available power source too quickly, and this led to the launch of the protection system. When rebooted, the software automatically turned off Voyager 2's scientific instruments to save power. After all, it has a rather limited supply of resources. The issue needed to be urgently addressed as Voyager 2 continued to move away from Earth. Thus, in order to avoid such failures and significantly improve communication, an antenna modification plan was proposed as a solution to the situation. During the implementation of the project, radio communication with Voyager 2 was completely turned off, and for a whole year. It was a risky undertaking, but necessary, so the engineers went all in. Fortunately, the year of silence passed relatively calmly for the probe, so the project was completed successfully and rather quickly. Contact with Voyager 2 resumed on November 2, 2020, after a series of instructions were transmitted to the vehicle using a special communication channel. As a result, on February 12, 2021, communication with the probe was finally restored. Now the Voyager 2 mission is active and fruitful again. The device continues its interstellar flight, simultaneously studying the environment and sending data to Earth. Although the probe's camera isn't strong enough to produce high-quality images, Voyager 2 is still important to mankind in terms of space exploration. This is the second interstellar object created on Earth, and the only one with which we keep such frequent contact. That is, at the moment, Voyager 2 is the last of the Mohicans, one might say, a representative of an endangered species. Certainly, there will come a moment when its power source runs out and the mission will come to an end, leaving the probe forever wandering in the icy embrace of infinity. What do you think of photo shoots? All of us have posed in front of a Christmas tree or seashore or trees with autumn leaves turning. But honestly, these pale in comparison to the photographs we receive from probes, rovers, and telescopes. They send to Earth pictures of unique locations that are unlikely to be reached in our lifetime or ever. And this makes these documents incredibly valuable to science, to say nothing of the awe they inspire in those who view them. Today, we'll demonstrate the most amazing and freshest photos made by the Hubble Space Telescope, the Chandra X-ray Observatory, and that stalwart veteran rover, the Curiosity. Would you like to see a galaxy, the light from which has been traveling to us for hundreds of thousands of light years? Would you like to see breathtaking Martian landscapes? Could these photos change our world in the future? In places where people can't reach, AI cameras become our eyes. For example, the Curiosity rover, built by the U.S. Space Agency, has been operating on the Red Planet since August 6, 2012. In December of the same year, the mission was prolonged indefinitely, and Curiosity is still operating on the big red planet. You might think the rover's traveled hundreds of miles since then, but no, it's barely moved 30 kilometers. However, Curiosity has brought priceless information to scientists, photos of various locations on Mars, mainly close to the Gale crater. It's an impact funnel which is about 4 billion years old. Curiosity was designed specifically to study this crater, and the rover has done an excellent job. For example, it recently sent a photo from the slope of the Martian Mount Sharp, which plunged researchers into intellectual ecstasy. The panorama included part of the mountain itself, as well as the Rafael Navarro Peak located in the distance. NASA employees were amazed at the beauty of the landscape and decided to make a full-fledged postcard from this photo, overlaying several shades on it, as well as compiling pictures of different times of the day. It turned out something amazing, at the same time reminiscent of alien and terrestrial landscapes. This is what these photos look like in black and white, as sent by the rover. Of course, this is not the only photo sent by the Curiosity rover. The aforementioned mountain, named after a scientist who passed away in early 2021, appears in many of the rover's images. It's quite visible from afar. Do the photos provided by Curiosity look too boring because it only explored the Gale crater? Not at all. The Curious rover tried to look into all corners of the huge 164-kilometer-wide impact funnel. For example, it repeatedly photographed not only Mount Sharp, but also its foot, where, by the way, the rover found clay. Curiosity's cameras also captured unique photographs of glowing clouds gathering over Gale crater. By the way, this huge depression might be an ancient Martian lake, but there are still heated discussions on this issue. However, let's leave Mars alone and go to some immeasurably more distant locations. Want to see pictures of a galaxy located at a huge distance from us? Thanks to the Hubble telescope, this has become possible. Incredibly, the light of this galaxy has been traveling to us for 230 million years, so it may no longer exist in the form that's captured in the photo. The picture clearly shows spirals rapidly rotating around the center of a huge structure. Modern telescopes are able to look deep into the universe and see what people didn't even dream of 100 to 200 years ago. The galaxy UGC 11537 is located in the constellation Aquila and is quite close to the Milky Way, so close that stars from the latter were also captured. The namesake of our channel, the Hubble telescope, observed this part of the sky as part of a program to study supermassive black holes, in particular in order to estimate their true masses, as well as to understand the principles behind the movement of stars in such galaxies. Do you think that this is the limit of vigilance of terrestrial optical systems? Absolutely not. They can see much further. Thanks to the Chandra Space Observatory, astronomers have been able to take a closer look at the largest gravitationally bound structures of the macrocosm, clusters of galaxies. As a rule, in the center of each of these conglomerations, there's the largest galaxy possible. Such groups include thousands of star clusters and clouds of hot gas with a mass much larger than that of the galaxies. This time, Chandra observed an object located almost 4 billion light-years from us. It's not easy to comprehend such a distance. It's enough to understand that it's incredibly far. We're talking about a cluster of galaxies called RBS 797. Based on images from the NASA Space Observatory, it's assumed that there are 2 supermassive black holes at the center of this structure. In general, such a tandem is not uncommon in the universe, but for both active objects to be so close to each other and in such close interaction is something astronomers observed for the first time. In addition, these black holes emit powerful jets. So, what was so surprising about this picture? Scientists noticed strange, gigantic cavities that had previously been observed in other galaxies. The origin of unusual voids is very difficult to explain. Most likely, this is the result of the activity of matter, which, with the help of multi-directional jets, blows out cavities in hot gas clouds. In total, experts from the University of Bologna found 4 such voids. In addition to them, 2 radio sources located at a distance of 250 light-years from each other fell into the eyepiece of the telescope. Once confirmed, these black holes will be the closest neighbors ever seen by Earth astronomers. What practical benefits does this give us? If the void-forming algorithm turns out to be plausible, astronomers will know more of the physical conditions near black hole event horizons. But what is the farthest corner of the universe where the vigilant eye of earthly telescopes could possibly look? Here, Hubble has excelled again. It's the Hubble who holds the honorary record. The telescope has discovered the most distant galaxy ever recorded by optical instruments. Its name is GNZ11, and the object was born just 400 million years after the Big Bang. The light from this galaxy has been traveling to us for almost 13.5 billion years. Perhaps the instruments failed, or the astronomers achieved an inaccuracy somewhere. No, this scenario was ruled out as the scientists double-checked all the parameters of the object on the light-wave spectrometer, and the results completely matched. The GNZ11 galaxy is located in the constellation Ursa Major, and if we take into account the expansion factor of the universe, then the so-called accompanying distance to it is 32 billion light-years. Astronomers have calculated that this object is 25 times smaller than the Milky Way, about 100 times less populated by stars. Previously, the most distant galaxy from us was considered to be EGSY 8P7, located in the constellation Bootes. It was discovered with the help of the Keck Observatory. Presumably, the object's located 13.2 billion years from the edge of the Milky Way. Photographs of distant objects such as planets of the solar system we haven't been to, or galaxies of the same age as the universe, have a huge astronomic value to current and future generations, since they let us learn more about processes that we're just beginning to comprehend. Before I start, I invite all our subscribers to solve one riddle. Which planet is so light in weight that it can float in a swimming pool? And which same planet in the solar system is the most different from the others? Here's a hint. It's named after the Roman god of agriculture. That's right, it's the majestic ringed Saturn. Despite the tremendous remoteness of the sixth planet from Earth, research probes have periodically been sent to it. In particular, the object was studied in detail by the Cassini interplanetary spacecraft. It wandered through outer space for 2 decades, closely examining Saturn and its moons. This story began on October 15, 1997 at Cape Canaveral. The ship carrying the Huygens descent module was launched from there. The probe had serious tasks to accomplish: the study of Saturn itself, its rings and satellites, as well as handling the descent of the Huygens to the planet's largest satellite, Titan. And the probe brilliantly managed all its duties. How many years did it take Cassini to reach its target, Saturn? To do this, the device resolutely traveled mile after mile for 7 whole years, until June 30th, 2004, when it entered the orbit of the giant planet. For many years, scientists around the world followed the activities of the spacecraft with bated breath and witnessed the amazing discoveries that it made. So, what did Cassini discover on and around Saturn? The probe carefully studied the satellites of the planet, sending images of newly discovered sites to Earth, literally plunged into the ice rings of the giant, and also studied the stormy atmosphere, discovering an unusual hurricane at one of Saturn's poles, something for which no analogs exist in the entire solar system. The last days of the probe were no less captivating than its life. They programmed a two-part finale. First, scientists planned a series of probe flights between the Saturnian rings, and this was a very risky maneuver. But contrary to fears, Cassini did a great job. But in addition, for part 2 of this finale, a sad mission was assigned to the device. What exactly was it? Cassini had to sacrifice itself so as not to pollute the satellites of Saturn with its possible fall, where, according to some astronomers, certain life forms could possibly be developing. And by the way, this applies not only to Enceladus with its subglacial ocean. In other words, the Cassini life cycle was very rich and eventful, and the probe didn't lose contact with Earth's scientists until the very end. So, what was the mission this interplanetary traveler is famous for, and where did the device finally meet its demise? I'll tell you all about it in a few moments. Thanks to Cassini, we've greatly expanded our knowledge of Saturn's rings. In past centuries, they were spoken of in the singular form because it was believed that this was some kind of big hoop hovering around the planet. This in particular was mentioned by Christian Huygens, whose name was later given to the descent vehicle, which was part of the Cassini AMS. The rings of Saturn were first discovered by Galileo Galilei in the 17th century, and since then, countless fantastical stories were hypothesized by scientists regarding this strange formation. However, I digress from the mission of the legendary device. Thanks to Cassini, numerous myths were dispelled, as astronomers discovered that the rings are actually composed of ice inclusions of various sizes, with impurities of dust and organic compounds. There are 4 rings, and the last of them is thinner than the others. Their diameter is huge, about 250,000 kilometers, while the thickness of the formation never reaches even 1,000 meters. In many places, there are voids, or peculiar mountainous agglomerations consisting of stones and ice. But overall, it's extremely heterogeneous, and the amount of matter in the rings is so insignificant that if all the stone and ice blocks were united into a single big lump, its diameter wouldn't exceed 100 kilometers. But these parameters could change depending on the intrusion of other space objects, for example, flying comets. Cassini also studied the moons of Saturn, and there are an incredible 82 of them. Some astronomers compare Saturn's system with our solar system, where the rings symbolize the asteroid belts. Isn't that quite the original analogy? Imagine the essentially fragile piece of metal named Cassini, crammed with hardware, hurtling at over 120,000 kilometers per hour towards its final destination, the vast, hazy, gaseous Saturn. Might you think we're describing a direct flight to the giant planet? No, this is in fact what the probe's death in Saturn's atmosphere looked like. It was the fate that scientists prepared for it, or rather, they were forced to do so. But before the death of the device, there was still a lot to explore, so let's not get ahead of ourselves. After its arrival in 2004, Cassini became the first artificial satellite of the gas giant, flying around it at a speed of 15 kilometers per second. During this time, it approached many of the planet's satellites, for example, Snow White and Enceladus, mysterious Titan, and others. But what was the most surprising discovery in the entire mission of the interplanetary vehicle? This is undoubtedly the legendary hexagon of Saturn, a giant stable hurricane located at the north pole of the planet. The hurricane's diameter is 25,000 kilometers. That means this storm could easily absorb several such cosmic bodies as our Earth, which is just 8,000 kilometers in diameter. Cassini found that the vortex literally grows into the atmosphere of the planet, pushing over 100 kilometers into it. In fairness, it should be noted that the hexagon was seen earlier by the Voyager spacecraft, but due to the extremely poor quality of the images, no one paid much attention to the structure. Cassini, which first photographed the extraordinary storm from a distance of more than 2 million kilometers, demonstrated to the whole world that we're dealing with a hurricane of planetary scale and enormous power. At the same time, the craft found that unlike the stable shape of its funnel, its color depended on the season and changed from bluish to golden. By the way, on Saturn, autumn follows summer, turning into winter and then spring, according to the same principle as here on Earth. This is facilitated by the tilt of the poles. When the northern part of the planet receives more sunlight, the hurricane, bathed in rays of light from our sun, acquires a golden halo. In winter, accordingly, the storm turns dark blue. So, how do scientists explain the appearance of this titanic hexagon? Most likely, it was helped along by the movement of atmospheric masses during Saturn's rapid rotation. But what about the enchanting death of Cassini? Has it brought any benefit to science? Yes, and it's huge. Returning to the hexagonal vortex, the probe photographed it again when its mission was coming to an end. It also discovered stone rains on Saturn, provoked by the permanent destruction of the planet's rings. When dust and ice particles enter the giant's atmosphere, despite a decent distance, this happens regularly, they break up into small fragments. So tons of ice and stones fall on Saturn every second. There's no conceivable umbrella that could offer protection from such a devastating rain. How does this threaten the rings of Saturn? Obviously, if the situation doesn't change, then very soon the planet will lose this distinctive feature. And it doesn't matter that the rings contain particles up to 100 meters in diameter, they too can fall over time. Do you wonder what the reason is for this strange phenomenon? It turns out that ice particles have a constant charge, and the core of Saturn is surrounded by so-called metallic hydrogen, which generates the planet's magnetic field. Both structures are attracted to each other, like hair to a rubbed balloon, hence the attraction and destruction of the rings, gradually giving up their particles to the planet. There's a mystery that Cassini was only able to solve at the end of its mission. And here I'm talking about the age of the rings. Astronomers were puzzled for a long time. Are the rings younger than the planet, or were they formed at the same time it was formed? It turns out that the age of the rings varies from 10 to 100 million years. So when life first appeared on Earth, and for most of its existence, Saturn didn't have its rings. Such conclusions were arrived at by scientists after obtaining data on the size and brightness of these objects. If the rings were older, then their brightness would decrease significantly due to the systematic accumulation of space debris. By the way, according to one theory, the rings appeared when Saturn attracted a very large icy satellite. As a result, the giant planet simply tore the object into small fragments gravitationally. To the honor of Cassini, it's worth remembering that even dying in the poisonous atmosphere of Saturn, it continued to fulfill its mission and was able to capture the clouds of the gas giant, achieving the closest possible distance to them. Thanks to this tiny but persistent and fearless apparatus, we got to know huge, distant Saturn better. Through the eyes of the probe, we saw a magnificent whirlwind of epic proportions, learned about stone rains, and also were able to view the satellites and rings of the planet, revealing some of their secrets along the way. Meanwhile, Saturn continues to rotate in the company of Tethys, Iapetus, Mimas, Enceladus, Titan, and the other cosmic bodies that organically complement it. It's likely that many more missions will be organized to the giant planet, and perhaps our descendants will even spend their holidays in its orbit. But the achievements of Cassini will never fade.
The speed of light is about 299,792,458 meters per second. This value is quite accurate, isn't it? But how have we determined it? According to the calculation by Ol Romer, the speed of light is about 220,000 kilometers per second. Half a century later, in 1728, James Bradley discovered stellar aberration and confirmed the finiteness of the speed of light. The value obtained by Bradley's was 308,000 kilometers per second. The most accurate measurement of the speed of light was carried out in 1975 based on a reference meter. According to this measurement, the exact value is defined as 299,792,458 meters per second. We can say that this is the highest possible speed in the universe, but can we reach it? In theory, to reach the speed of light, our aircraft should be massless. The paradox is that you don't have to physically exist such an acceleration. The speed of light may seem enormous, but taking into account the distance between space objects, it is no longer so impressive. Moreover, it seems quite modest compared with human ambitions to travel fast from one point of the universe to another. Of course, light can circle the Earth 7.5 times in 1 second, but it also has limits. For example, when talking to a person who is 1 meter away from you, the latency of what you see is 3.3 nanoseconds. In general, nothing in the universe appears before us in the present time or now. Let's try to start with familiar objects, such as the Moon. The natural satellite of our planet is 380,000 kilometers away from its surface. That means that from Earth we see the Moon as it was 1.3 seconds ago. The latency for the Sun is 8 minutes, and for Mars it makes 14 minutes. We can conclude that it takes almost 14 minutes for the rovers to do the simplest movement, because they're controlled directly from the Earth. It turns out that the speed of light is a kind of border for any other speed, such as radio, micro, and gamma waves. Let's try to go even further. The closest star system to Earth is the Alpha Centauri system, which is 4.3 light-years away. There are 3 stars in the system, and the smallest one, Proxima Centauri, is the closest one, 4.2 light-years from the Sun. A planet which is the size of the Earth is orbiting Proxima Centauri. Let's imagine that it is inhabited by intelligent life forms that are interested in space exploration like humans. So aliens will be able to see the 4-year-old picture of the Earth. If their telescope can show every person on Earth, then they can see you 4 years younger than you are in the moment of observation. The center of the Milky Way is located 25,000 light-years away from the Sun, which means that we see it as it was 25,000 years ago. Let's zoom in. Imagine that there's a planet with intelligent inhabitants which is located 2,000 light-years away from us. To observe the Earth, they'll need a telescope with a diameter of several 100,000 kilometers. All of us have seen pictures and videos of the dark, night side of the Earth, and all of us remember perfectly well the scattering of the luminous points of our cities. But 2,000 years ago, there were no megacities. Centuries would have to pass before the invention of artificial light. If they would like to see people on our planet, they would need a telescope of approximately 11 billion kilometers in diameter, which is a distance from the Sun to Neptune. Let's imagine that our mysterious neighbors do have such technologies. They will see ancient Rome and other civilizations of that distant time. In 1 AD, Rome had a population of 800,000 to 1 million inhabitants and was the largest and most powerful city in our world. Most of what we know about the civilization of this ancient era was recorded during Roman rule. The population of the Earth was about 231 million people. The most inhabited areas of the planet were communities founded around the rivers Ganges, Tigris, Yangtze, Nile and Po. Would you like more of it? Our nearest galaxy is Andromeda. It is much larger than Milky Way and is believed to eventually collide with it. Andromeda lies in the distance of 2,500,000 light-years from the Sun. We can observe it as it was 2.5 million years ago. An alien observer from there having a telescope with a colossal 15 trillion kilometers diameter won't see any intelligent life on the Earth at all. A human being is just emerging as Homo sapiens. He learns to use the tools and is hardly aware of the great path ahead. It's worth mentioning that extraterrestrials will be able to see not only the Earth in the past, but the entire Milky Way galaxy 2.5 million years ago. The scale is breathtaking, but what if we move even deeper? The largest spiral galaxy, NGC 6872, is located 212 million light-years away from our solar system. The diameter of the telescope should be truly fantastic, about 1 quadrillion kilometers, or 132 light-years. What will the alien observers see this time? First of all, they won't see the outlines of the continents that are familiar to all of us. Instead, they will see only the supercontinent Pangaea, which much later was split up by the Tethys Ocean into Laurasia and Gondwana. Both supercontinents will later split up into smaller parts, and their collisions will lead to active mountain building. Africa's pressure on Europe will result in building the Alps, and the clash between India and Asia will create the Himalayas. Secondly, most of the inhabitants of the Earth the aliens will be able to see are considered extinct a long time ago. The Jurassic period is the dawn of the forests. Abundant rainfalls contributed to the spread of flora not only in the ocean, but also on the surface. There were mainly real ferns and gymnosperms in the dense forests. The class of gymnosperm cycads has survived till the present day. These days, the Jurassic flora grows in humid equatorial forests. The farther away the observers are, the deeper they have to look in our planet's past. As you understand, the same rule applies to us in case we want to watch them. Voyager 1, a spacecraft with a golden phonograph record on board with a message for alien life, will help us to understand the colossal nature of all these scales. It contains greetings in 55 languages, people's voices, classical music and sounds of nature, photographs of people and the Earth. The gold-plated copper disc contains the coordinates of Earth and the solar system, as well as the radiation pattern of the hydrogen atom. In September 2013, NASA announced that Voyager 1 has crossed the border of the solar system. It was the first spacecraft to enter interstellar space. Today, the spacecraft is at the distance of more than 20 billion kilometers from the Earth. The calculations of the scientists say that the fuel should be enough for another 10 years of work, and after that, the ship will lose connection with the Earth. Let's imagine that there's enough fuel for an infinite period, and Voyager 1 is heading straight for Proxima Centauri. This path will take 40,000 years, given that the spacecraft doesn't move at the speed of light, but only at the speed of 17 kilometers per second, or 60,000 kilometers per hour. The sheer scale of the cosmos is hard to imagine. And although the darkness of the unknown space can be rather frightening, humanity should fearlessly seek ways to accelerate the spacecraft if we link our future to the exploration of other worlds. When a human meets the cosmic immensity, he understands how little he knows about the world around him, how much unknown is in this world, which has yet to be discovered. Why do the laws of the universe work this way and not another? Why does the very fact that we have sense organs seem like a mockery of the distances in space?
What object do you imagine when you hear the word planet? Earth? Jupiter? Pluto? Whatever your imagination conjures, when you mention planets, you almost always see something spherical. But the universe is diverse, so there are no stable patterns. Even in our solar system, there's a celestial body that completely destroys all stereotypes. This is Haumea, a dwarf planet orbiting 7.5 billion kilometers from the Sun in the arms of the Kuiper Belt. But in this global torus, there are many other exotic bodies. So why are we talking about this one? There are several reasons. Let's get to know Haumea better. This humble dwarf planet is classified as a trans-Neptunian object. That is, a celestial body whose orbit lies outside icy Neptunes. Haumea is also ranked among Plutoids, dwarf planets that correspond to a certain classification. In particular, their mass must be sufficient for gravity to transform them into a kind of sphere. Among other things, these objects are not required to clear the space around them, as required by the title of full-fledged planet. Iris, Makemake, and Pluto, which were recently expelled from among the main participants of the solar system, are also ranked as Plutoids. And now the strangeness begins. Haumea is the fastest rotating planet of any kind in our immediate environment. Even Jupiter, the legendary sprinter of the solar system, can't keep up with it. The period of Haumea's revolution around its own axis is only about 3 hours, and this is an absolute record among objects known to astronomers. As a result, the shape of this dwarf planet is not similar to other bodies of stellar systems. Haumea is a classical ellipsoid. Unfortunately, it's not yet possible to observe the object up close, but astrophysicists note significant fluctuations in brightness. The diameter of the ellipsoid is about 1,700 kilometers along its equator and 1,130 from pole to pole. The indicated data, obtained in 2017, have been repeatedly refined and corrected. The half-axis of its orbit is 6.5 billion kilometers, and the minimum distance at which Haumea approaches the Sun is 5.2 billion kilometers. Accordingly, a year on this dwarf planet lasts about 280 Earth years, almost 3 centuries. What does this strange dwarf planet look like? Most likely it's covered with grainy ice, a kind of ice with sand in it. When scientists began to monitor the physical parameters of Haumea, an interesting paradox was discovered. It was previously believed that its density is higher than its neighbors in the Kuiper Belt, but updated data forced us to revise this information. The density indices turned out to be much lower than the initial ones, which did not fit into any model characterizing a homogeneous body in hydrostatic equilibrium. Therefore, a conclusion was made about a cardinal difference of the composition of Haumea. Perhaps inside this dwarf planet there's a heavy stone core, which, like a featherbed, is covered by a loose mantle of ice. I wonder how comfortable the conditions are on this distant, tiny dwarf planet. It appears to be not for everybody. And if the concept of sand mentioned earlier is firmly associated with sunny beaches, I must disappoint you. The temperature on the surface of Haumea is not at all resort temperature. It's minus 223 degrees Celsius. The atmosphere on the celestial body also won't make you happy. It simply doesn't exist. Consequently, Haumea is not blown by hurricanes or freshened up by downpours. Granular ice covers the dwarf planet, mostly watery but with non-trivial inclusions. In particular, potassium cyanide was found in the spectrum. This addition is a little bit creepy. Among the dwarf planets, Haumea is in the leading position and occupies the 4th place in size. Imagine a huge, madly spinning stone egg. The dissimilarity of this dwarf planet to others is associated with its sad past. Scientists believe that Haumea suffered a major disaster long ago. The sudden expansion of a huge asteroid or other celestial object gave it a higher rotational speed and also contributed to the appearance of 2 satellites. By the way, if you carefully examine the surface of this dwarf planet, then a trace of this monstrous collision is visible even now, a small pink spot, although it might be just a collection of colored minerals. When mentioning the satellites of this dwarf planet, it's also worth recalling the history of its discovery and attempts to assign it a name. The celestial body was found relatively recently. The official date is July 29, 2005. 1985, and the discovery was at the center of a dispute by two groups of scientists who both claimed the discovery at the same time. The dispute was eventually resolved, and with it, the planet was given its full name, along with a catalog number. It was decided to be named after the Hawaiian goddess of fertility. The satellites of Haumea were named according to the same principle. They were named Namaka and Hiaka. These are the names of the daughters of the Hawaiian deity. Interestingly, before being included in the catalog, astronomers called the larger satellite Rudolph after one of Santa Claus's reindeer. Why such a strange choice? Plain and simple. Unofficially, the dwarf planet Haumea was discovered in 2004, right after Christmas. So in certain circles, it was called Santa for a long time. How do the satellites of the dwarf planet surprise astronomers? The first moon, Hiaka, has a diameter of 310 kilometers. A year on this satellite lasts 49 days. Namaka is much smaller. Its mass is a tenth that of its neighbor, and its diameter is fixed at about 170 kilometers. It revolves around its parent planet in 18 days. Both satellites are gradually moving away from Haumea. This happens slowly and imperceptibly, similar to our moon, which is also slowly and almost imperceptibly moving away from the vicinity of the Earth. Astronomers suggest that the appearance of Haumea's satellites is also the result of an ancient collision. Now, guess what connects the planet Haumea with the giant Saturn? It turns out it's the ring system. Of course, they're not as epic as those of the ringed giant, but the very presence of such a structure next to an object of such an insignificant size says a lot. The rings are about 70 kilometers in width and have a radius of 2,300 kilometers. The uniqueness of the phenomenon lies in the fact that Haumea is the only trans-Neptunian object surrounded by such a hoop. It's believed that the moons, the rings, and the unusual form of Haumea are all links of the same chain, which appeared as a result of an incredibly powerful catastrophe. Will we ever be able to explore this mysterious world? Hypothetically, this is possible. If you send an automated interplanetary probe in the indicated direction in 2025, then it will reach Haumea in a decade and a half. In this case, a gravitational maneuver around Jupiter is mandatory. Without it, achieving the required acceleration of the probe is impossible. Right now, we are rapidly rushing into the future, and who knows, maybe in 10 years the surface of the planets and their satellites will become as commonplace as reality shows on Earth. Oh, if only the number of Hubble's likes and subscribers could bring this long-awaited moment closer. But we are able to influence something else, the earliest possible release of a new educational video. Share videos with your friends, and don't skimp on moral encouragement. The universe will reward you. And if 15,000 likes are collected under this video, then the speed of the release of the new video will surpass the speed of light. Don't believe me? Check it out.